All right, good morning and welcome to Master Talker online class. In today's video, we'll be solving questions on indices and logarithm. Okay, so question number 43 in our series. So I have they said if 16 raised to power x minus 4 raised to power x minus 12 is equal to 0, then I say we should find x. This is very simple solution. So what do? 16 raised to power x minus 4 raised to power x minus 12 is equal to 0. Now, in this type of indices, just make what is here to be here as well. So I know that 16, I can reduce it as 4 raised to power 2. Don't forget it has raised to power x. Then minus 4 raised to power x minus 12 is equal to 0. Now, these people can change because x times 2 and 2 times x are still the same thing. So I have 4 raised to power x in bracket of 2 minus 4 raised to power x minus 12 is equal to 0. Now, they don't look alike. Immediately you get the same thing. Just say, let that thing be equal to what? Y. Very simple. You are done. So anywhere I see 4 raised to power x, I'll put y. So I have y squared minus y minus 12 is equal to 0. So what do? We have that y squared minus 4y plus 3y minus 12 is equal to 0. So what do we have? Y into y minus 4, y minus 4, and then plus 3, right? According to quadratic equation is equal to 0. So y minus 4 and y plus 3 is equal to 0. So what do we have? Y minus 4 is equal to 0, or y plus 3 is equal to 0. So what do we have? We now have that y is equal to 4, or y is equal to minus 3. But you tell them, but y must be greater than or equal to 0. So y must be non-negative. So since y must be non-negative, therefore, the only one I'm using is 4. So, but don't forget, you tell them, but there is a place you say that 4 raised to power x is equal to y, because we are not looking for y. They say we should find x. So we can say now what? 4 raised to power x is equal to what? 4. So therefore, 4 raised to power x is equal to 4 raised to power 1. If this take care of this, therefore, you say that what? X is equal to 1. So this is very, very simple. So question number 44. Question number 44. Okay, there's no 44. They say question number 45. Question number 45 says solve 3 into 4 raised to power t, okay, minus 4 into 2 raised to power t, okay, then plus 1 is equal to 0. Okay, solution. The same thing. Just try to make this thing to look like 2 raised to power t. That's the first thing we do. So we bring down 3 raised to power 3 in bracket of 4 raised to power t minus 4 in bracket of 2 raised to power t plus 1 is equal to 0. So I can break this one to 2 raised to power 2. So this is 3 into 2 raised to power 2. Then don't forget it has raised to power t minus 4 into 2 raised to power t. Then plus 1 is equal to 0. I can bring the t inside and take this one outside because 2 times t and t times 2 are still the same thing. So I have 3 into 2 raised to power t all squared minus 4 into 2 raised to power t, then plus 1 is equal to 0. Now, immediately they look alike, like I told you before. You now say, let that 2 raised to power t be equal to what? Y. So I have what? 3y squared minus 4y plus 1 is equal to 0. So what do we have? 3y squared minus 3y minus y plus 1 equal to 0. So what do we have? 3y into y minus 1, y minus 1, and then minus 1 here equal to 0. So what do we have? 3y minus 1 and y minus 1 is equal to 0. So what do we have finally? We now have that 3y minus 1 is equal to 0, or y minus 1 is equal to 0. So what do we have? We now have that y is equal to 1 over 3, or y is equal to 1. But I'm not looking for y, I'm looking for x. I'll tell them but there's a place I say that 2 raised to power t is equal to y. So therefore, 2 raised to power t is equal to 1 over 3, or 2 raised to power t is equal to 1. Okay? Now, the base cannot, this is 2 raised to power t is equal to 3 raised to power minus 1. The base are not the same thing. If the base are not the same thing, you take the log of both sides. So taking the log of both sides, I can say log 2 raised to power t is equal to what? Log 3 raised to power minus 1. But for here, or for this side, 2 raised to power t is equal, I can make this 2 raised to power 0 because anything raised to power 0 is 1. And this taking care of this, I have that t is equal to 0. Are you getting it? So now, these powers can go to the back. If this one come to the back, I have that t log 2 is equal to what? This one going to the back, minus 1 log 3 In fact, nothing like minus 1 log 3. Instead of, you have minus log 3. All right, divide everybody by log 2. Then t I'm looking for will now be what? Minus log 3 all over what? Log 2. All right, so which is what? T is equal to, the base are the same thing. So if the base are the same thing, I can have minus log 3 base 2. Or, don't forget, I got here t is equal to 0. So any of the two are the correct answer for that. All right, we move to question number 46. Question number 46. And question number 46 said 9 raised to power x minus 4 into 3 raised to power x plus 1, all right, plus 27 is equal to 0. Okay, the same method, just try to make what is here to be here. Okay, if I break this one down, I'm going to have 3 raised to power 2 all raised to power x, all right, minus 4 into, according to indices, what brought about this plus is times. So let me separate it as 3 raised to power x times 3 raised to power 1, all right, then plus 27 is equal to 0. So this one can be 3 raised to power x all squared minus, now this is 4 times 1, 4 times 3 is 12. So I'm going to have 12 in bracket of 3 raised to power x, then plus 27 is equal to 0. You see, they now look alike. Immediately they are the same thing. You now say, let that 3 raised to power x be equal to what? Y. So I'm going to have y squared minus 12y plus 27 is equal to 0. So what do we have? Y squared minus 12 is what and what can give you 12? 9 and 3, yes, minus 9y minus 3y, then plus 27 is equal to 0. So I'm going to say y into y minus 9, then the same y minus 9 here. I'm having minus 3 is equal to 0. So I have y minus 9 and y minus 3 is equal to 0. So therefore, y minus 9 is equal to 0, or y minus 3 is equal to 0. So therefore, y is equal to 9 or y is equal to 3. But I'm not looking for y, don't forget. I am looking for x. So I can tell them, but I can still tell them, but there is a place I say that 3 raised to power x is equal to y. So therefore, 3 raised to power x is equal to 9, or 3 raised to power x is equal to what? 3. So this is 3 raised to power x is equal to 3 raised to power 2, or 3 raised to power x is equal to 3 raised to power 1. This take care of this, and this take care of this. We now have that x is equal to 2 or 1. Very, very simple to solve. The next question. You can pause, rewind, okay, if you don't understand, or you go and watch my video on indices where I explained it very well. This one is just solving of calculations. So this one said that if 3 raised to power x plus y is equal to 3 raised to power 5, and the 2 raised to power 2x minus 5y is equal to 8, then they say we should find our x and y. Okay, to find our x and y, we will say solution. From this place, I have that 3 raised to power x plus y is equal to 3 raised to power 5. If this take care of this, therefore, my x plus y is equal to 5. This is my equation 1. Okay? The same thing is applicable here. 2 raised to power 2x minus 5y is equal to 2 raised to power 3. If this take care of this, we'll now have that what? That 2x minus 5y is equal to 3, equation 2. Okay, so solving simultaneously, we are going to times these people by 2, times these people by 1, so that the coefficient will be the same thing. So 2 times x, I have 2x. 2 times y, I have 2y. 2 times 5, I have 10. 1 times everything is still the same thing. Okay, so if I subtract, I'm going to have minus is plus. So this plus this will give you 7y, okay, is equal to 7. So what do I have? Y is equal to 1. So if y is equal to 1, you tell them substitute y equal to 1 in equation 1. And my equation 1 said that what? That x plus y is equal to 5. So x plus 1 is equal to 5. Therefore, x is equal to what? 5 minus 1, which is equal to what? 4. So therefore, we have gotten that my y is equal to 1 and my x is equal to 4. Very, very simple to solve. Right? Okay. So that is that. Question number 48. Question number 48. Now, question number 48 said, lane that we should simplify without table. Lane 27 minus lane 3 minus lane 4 all over lane 27 again minus lane 8. Okay, so solution, you know that lane is logarithm, and logarithm say that if I have minus I should divide. So I'm going to take one of the lane and now have 27 divided by 3, another minus divided by 4. Okay, all over lane, the same thing here, 27 divided by 8. Okay, so what do we have now? This is going to be the same as lane 27 over 12. All right, all over lane 27 over 8, because this divide, this can times this. I hope you know. Look at it, 27 divided by 3 first, which will give you 27 over 3. Is it not true? And 27 over 3 will give you okay, 27. Okay, then another divided by 4, which should be what? 27 over 3 times 1 over 4. You see that is 27 over 12. So but something can divide. So this is what? Lane 3 divided, I'm having 9, and 3 divided, I'm having 4. Okay, all over lane, this one is 27 over 8. So if you do that, you're going to see that I'm going to have lane, let me reduce this one. This is 3 raised to power 2 over 2 raised to power 2. Okay, all over lane, this one is what? 3 raised to power 3 all over 2 raised to power 3. Okay, are you getting it now? So you see that they have something in common. If they have something in common, I'm going to say that this is what? Lane 3 over 2. Everybody having squared all over lane, the same 3 over 2. Everybody having cube. So the squared can go to the back. If they go to the back, I'm going to have 2 lane 3 over 2. Okay, all over 3 lane 3 over 2. This will cancel this. So therefore, my final answer is what? 2 over 3. So 2 over 3 is my answer here. So let's move to question number 49. Question number 49. Question number 49 said that if log 1 over 8, okay, base x is equal to minus 3 over 4, then we should find x. Okay, this is very, very simple. This is very, very simple. So what do? We know that if we want to remove log, I have that log 1 over 8 base x is equal to what? Minus 3 over 2. Minus 3 over 4, sorry. Now 1 over in log, watch. This is same as log. This is 8 raised to power minus 1. Okay? 8 raised to power minus 1. Or I can say that this is log 1 over 2 raised to power 3 base x is equal to what? Minus 3 over what? Over 4. So this is what? Log 2 raised to power minus 3 base x is equal to what? Minus 3 over 4. So this can go to the back to have minus 3 log 2 base x is equal to what? Minus 3 over 4. Are you getting that now? Now, if this one come here, it will become divide. I want to leave that log 2 base x to stay alone. So I'm going to have log 2 base x is equal to what? Minus 3 over 4 divided by minus 3. So which is what? Log 2 base x is equal to what? Minus 3 over 4 times 1 over minus 3. So this take care of this. So I'm having that log 2 base x is equal to 1 over 4. So this one can carry this one. So what do we have now? We now have that what am I saying? We now have that x raised to power 1 over 4 is equal to 2. Now, if 1 over 4 going to this side, it will now be 4. So I have x will now be what? 2 raised to power 4. And 2 raised to power 4 is what? 16. So 16 is the right answer for question number 49. Now, question number 50. Question number 50. Out of 300 questions. Question number 50. Number 50 said, without using table or calculator, evaluate log 27 plus log 8 plus log 125. Okay, divided by log 6 plus log 5. Okay, so this is very, very simple. According to logarithm, if I have plus, I need to times. So it's going to be 27 times 8 times 125 divided by log 6 times what? 5. Okay, so this is now saying log 27000 all over log 30, right? So this is now saying log, what am I saying? Log 27000 base 30 according to the law of logarithm. So this is set as what? Log 30 raised to power 3 base 30. Now the 3 can go to the back. I have 3 times log 30 base 30. And if the log and the base are the same thing, it is 1. So 3 times 1, which is what? 3. So 3 is the correct answer to that. So we move to the next question, which is question number 51. Question number 51. Question number 51 said, question number 51 said that if log x base a is equal to 3, then find or evaluate log a squared base what? Base x. Sorry, log x base a squared. Okay, solution. This is very, very simple. They say we should find log x base a squared. Now, if this 2 is going to the back, it's going to be 1 over 2 log x base a. And they gave me that log x base a is equal to 3. So my answer is 1 over 2 times 3. So which is what? 3 over 2. So 3 over 2 is the correct answer to that particular one. So we move to question number 52. Question number 52 said that we should evaluate log pi squared then base 1 over pi. Okay, this is very, very simple. So this is equal to log pi squared base pi raised to power minus 1. Okay, they can both go to the back. So this is what? 2 times this one going to the back, 1 over minus 1 times then log pi base pi. And if the log and the base are the same thing, the answer is 1. So I have 2 times minus 1 times 1, which is what? Minus 2. So minus 2 is the correct answer to that. We move to question number 53. So question number 53. Oh, they don't have 53, they have 56. So question number 56 said that if they gave me that log 7 is equal to 0.845, and they gave me that log 2 is equal to 0.301. Then I say I should find log 3.5, okay, base 10. Now this is very, very simple. So what do you do? Solution. So what do? I have log 3.5 base 10. You know that 3.5 means 35 over 10, and 5 divide here 7, 5 divide here 2, so it means 7 over 2. So this is known as what? Log 7 over 2 base 10. But according to law of logarithm, the reason I have divide is because of minus. So this is what? Log 7 base 10 minus log 2 base 10. So which is going to give me 0.845 minus 0.301. So if you subtract that, you are going to have let's subtract. If you subtract that, you are going to have 0.845 minus 0.301. So I'm going to have 0.544 as my correct answer for that. So question number 56, 57 rather. Question number 57. For question number 57, I have given that the same log 7 is equal to 0.80845, okay, and log 2 is equal to 0.301, okay. Then I say we should find they say we should find the value of log 14 base 2 times log 2 base 10. All right, now in this one you need them to be of the same base first before you know what you can do. Okay, so since this one is in base 2, let me turn this one to be in base 2. So this is log 14 base 2 times 1 over. Anytime you want to turn it around, you have 1 over. I have a video on logarithm. You can go and watch the laws of logarithm. So I have log 10 base 2. Okay, they are both in base 2 now. So this thing can be over 1. So this times 1. So this is now log 14 base 2 all over log 10 base 2. According to one of the laws of logarithm, if I want to remove the base 2, this is set as saying log 14 base 10. That's the meaning. Okay? And 14 means 2 times 7. So this is what? Log 2 times 7 base 10. And what brought about times is plus. So this is log 2 plus log 7. So which will give you what? 0.301 plus 0.845. So if you add both of them, we're going to have 1.146. Okay? 1.146. So this is very, very simple. So I think that is the last question for logarithm. So in our next video, we now talk about the theorems of quadratic equation. The theorems of quadratic equation. So thank you very much for watching. Please like, share, and subscribe. Bye bye.